Now we are recording. Okay. So welcome back. This is where we left off. We finished talking about some things like relevance and page rank and spam blogs is how we closed it out the other day. New topics today. And we're going to look at the data Google gathers and how they go about gathering it. And basically the whole from Google going out and grabbing web pages to implementing them in an index where it can easily look things up. That's what today will be all about. So Google, of course, wants to deliver high-quality, relevant search results. In order to do that, it has to keep track of what's going on out there in the internet. If there's been an update to a page or a new page created, Google kind of needs to know about that. So there's, why are you pinging me? Why are you pinging me? I heard the ping. That's good. Somebody pinged me. I don't know. All right. I can't see it. Okay. So some data is inherently dynamic. For example, if you go and do a Google search for weather, you're going to get some short-term, near-term forecast, right? Like the next 48 hours, the next 7 days, something like that. And every hour, what's going to be in the mix is going to change. And the weather itself can change, right? They could say, well, we had a 50% chance of snow, but now that's been updated to like 90%, whatever. So some data like that is inherently dynamic. Other times you can see data that is expected to be static and not change, but for some reason does change. For example, suppose you have a Wikipedia article, right? And people are going back and forth on some contentious topic. One person makes a change, another person revises that change, another person revises that change, right? So the web page, it is what it is. It's not inherently dynamic stuff, but people's interactions with it can change. Or other kinds of static data changes. Suppose you have a store that's selling winter hats, right? And then it gets to be March and they say, well, we still got a bunch of winter hats. We don't want to keep them around for the next 10 months. So let's sell them cheap now. So they have a sale. So the price goes down. And they need to notify, Google needs to know about that in order to deliver better search results. And of course, new pages are being created and old pages are being deleted all the time. Google doesn't want to send you to a page that doesn't exist. And it doesn't want to, miss out on all the new relevant pages that might be in creation. So to do all this, Google basically has to store a reasonably current replica of the surface internet. And we'll talk a little bit about what that means, but the idea for now is just all the pages that anybody can just go to, right? So if it's a page that's completely open to the public, that's what we mean by the surface internet. Now, even a decade ago, Google was checking about 1 trillion URLs several times a day. So that's a lot of work. They have, and there's just more pages now. So if we dig through, there's another reason to have this slide here. So say about 10 years ago, Google had something around the order of 500 million pages, all right? 500 million websites, sorry. But a lot of those websites, or at least, a good chunk of them, have really a lot of pages. For example, Amazon has hundreds of millions of products. Every one of those products has a separate page. Facebook has literally billions of users. Every one of those user accounts indicates a separate page, right? Other things, YouTube, right? There are hundreds of millions of videos on YouTube. Every one of those is a separate page. So you can see, just from a few of those, there's a fair number of websites that have an insane number of pages, and quite a few just have a lot of pages, right? Any retailer out there is going to have a separate page for every product. Any blog writers or newspaper site, news site is going to have a bunch of different pages for different articles, whatever. So a lot of pages you got to search through. Now let's go back through this. All right. So again, this is a big data problem, right? This is not a trivial thing, keeping up with that many pages. And again, that was 10 years ago, so I'm sure it's at least a few times more activity now. All right. So, excuse me, time for a picture. So this is an idea of what Google's got to do. First of all, Google has to find the web pages, right? Both new ones, canceled ones, and revised ones, right? And revised ones, not both. I guess that's all of. There we go. So Google's got to go out and find those web pages, right? And it has software agents that do that, basically automated browser programs. I'm going to draw a loop here to indicate this is a continuous cycle, right? This thing never stops. Once one of these programs has found a web page, it's going right back out the door to find more web pages. All right. Now, the data Google gathers, web page data, gets stuffed into a couple of different systems. All right, so number one, got to process it first. Process page data, right? So number one, extract data used for retrieval and ranking. And number two, compress a whole page, right? So any kind of, any web page, Google wants to maintain the entire page because that's useful for things like algorithm revision. If Google wants to make some revision to how its ranking algorithm works, they need a big slug of data in order to work with. And so that's a good reason to keep those complete pages, right? If they want to say, hey, maybe there's a new variable we can extract that we could include. So yeah, they keep the pages. Number two, right, or number one here, any data that gets used for retrieval and ranking, they have to extract that somehow, right? Because what Google doesn't want to do is have this massive pile of 1 trillion web pages. A search comes in, Google has to scan through every page for every search. That's going to take a lot of time. Maybe more importantly, it's going to take a lot of electricity and a lot of hardware. It's going to be very expensive. Just like if you have an index at the back of the book, it makes sense to look something up through the index, not, go look at every page of the book to try to find something. So all that kind of data that Google is using for figuring out which pages match with which queries and how to rank them, it extracts that and stores it in a separate system. All right. So processed web page data, right? It goes into Google's indexing system. And what that's for is to provide a much easier way of finding things quickly, right? Just like a library, you want to look up some particular book. They have some screen there where you can type in the name of the book and it can tell you where to find it. And then if you're looking for a particular thing in that book, you go back to the index of that book, figure out what page it's on, and there you go. Same kind of thing there. All of this processed web page data, goes to Google's index so it can retrieve pages easily. All right, so that's a big picture thing of what's going on. Now that happens as 3 different activities. So the first one is crawling, gathering web page data. So we'll talk about that in a moment. The second one is indexing, compiling and sorting all of that web page data so it's easy to find what pages they're looking for. And then finally, retrieval. Anytime a query comes into Google, Google's got to say, okay, we have all of these, millions or maybe billions of pages that match this query to some extent. How do we determine which are the lucky few that show up at the top of the search results? So, all right. So first thing, crawling. So Google has software agents that visit pages. Software agent, again, just think of it, it's a browser application. But when you and I use a browser application, we go to some web page, we download all the data, and our browser renders some kind of web page for it, right? It arranges the text however it's supposed to be. It sets up the images and the ads and anything else. Well, Google doesn't care about that. Google's not actually a user. What the browser agent does, the crawler, is it takes that data and basically sends a version of it to Google. So these agents are called crawlers or spiders. They're called spiders because if you think about it, you have the web. What's going to crawl all over the web? Spiders, of course, right? So that's why these applications are called spiders. And after a page gets visited, then the spider keeps on going through any links on those pages. So time for another picture. Oh, I'll make an edit here since I'm in the middle of this. This is where the spiders do their job. Spiders are what Google calls Google bots. Okay, they're the ones that do this, but we're gonna replace that with some other stuff. So suppose, for example, you go to Amazon.com, or Google sends a spider to Amazon.com. And on that Amazon.com homepage, there's a bunch of links to other pages. And let's write down a few of them. So maybe there's one for product categories. Okay. Obviously is going to link to a whole bunch of pages. There's maybe another link for Amazon Web Services, right, for cloud services. There's another one for contact us, right, if you need customer service. And maybe there's another one for jobs. So anytime a spider goes to Amazon.com, it's going to scan that Amazon.com homepage, and then it's going to see these links to these other pages. Well, it's going to follow those links and see what's on those pages. For example, for product categories, this is going to link to a whole lot of different web pages, right? We can just kind of take that as a given. Amazon Web Services, same thing. There's a whole bunch of different services Amazon offers, and therefore, right, you get links to a bunch of those, and the spiders are going to check out those. Maybe for contact us, there aren't so many, right? Maybe there's basically one that says, here's how to get hold of us, but maybe there are different contact us pages for different kinds of problems, right? Maybe there's one for a missed delivery. Maybe there's another one for if your car got hit by an Amazon truck. Maybe there's one if you just want to go full Karen and complain about something completely unreasonable. All right, they send you there. I don't know. There could be a bunch of contact us pages. And then, of course, jobs, right? Some jobs are in delivery. Some jobs are in tech. You could be a cloud engineer, whatever. So you go to one page. That page has links to other pages. Those pages have links to many others. Eventually, you can use this sort of technique to traverse every page that's on Amazon.com, right? However many hundreds of millions of pages they have, you get to see them all this way. Okay. So the eventual result is Google basically has a graph of the entire conventional or surface internet, right? Not stuff like the dark web, which is pages that are hidden behind security features or paywalls. Well, that's the deep web, actually, not the dark web. So anyway, so the other thing, how often does Google come back and check? Well, Google does come back and check because it knows that things change from time to time and it wants to keep ahead of that. But it's not going to check every page at the same rate. So some things that Google looks at, number one, popularity. If a page gets a lot of traffic, then keeping up with that page is going to make a lot more people happy than if it's some blog that has 2 subscribers. Google kind of really doesn't care much about that blog. It's not a very popular page. But again, if Google has the choice between keeping up with a very popular page that has 1 million visitors every hour or a very not so popular page that has 2 visitors every month, obviously it's going to go to the busier one. Number 2, reliability. Reliability just means when Google shows up to the page, is the page available, right? So one thing is that the page could just be gone. It could have been deleted for some reason. And after a while, if Google keeps on seeing that, they're going to say, yeah, okay, this page is probably done. But the other issue is that if a page is from a reputable site, then chances are that site wants to have its pages be available. It's making money somehow because, doing this hosting isn't free. So maybe they're selling stuff, or maybe they have content that they hope you click on some ads while you're there, whatever. They're hoping to make money somehow. And so if you're a decent site, you probably are trying to keep that up and running. Whereas if you're some spam blog factory, then yeah, probably a lot of those pages are going to be down a fair amount of time. So Google's going to look at that and say, yeah, if your page isn't there, either number one, you're not the highest quality site, or number two, the page has gone away, is what they're going to figure. And last, update frequency. So the first time Google sees a new page, they're going to come back pretty frequently, to get a handle on how often updates happen. But if Google goes back and checks a page, a few times a day, every day for a month, and there are no changes, eventually Google's going to, dial that frequency back. They're going to say, hey, nothing's happening here. We're not going to, bust our back trying to keep up with you guys when you're not doing anything. So, yeah. Okay. So that's basically it for crawling. Now, the tech supporting spiders. So Google calls it spiders, Googlebots, right? Other search engines have their own kinds of spiders, whatever. But again, a Googlebot, basically a browser that visits pages, copies their content. So just like when you have your browser, You visit a page, you download the data to make the page. Spider does the same thing. It downloads that data, except it doesn't look at it. It kicks it off to one of Google's other systems. So Googlebot doesn't do any processing besides reading content and checking links. The content that it does pull, it delivers ultimately to Google's indexing system. And another interesting point, sites can include a robots.txt file that specifies content that spiders should ignore. Anybody think of any reason why a web page might want to tell the spider, hey, I know this stuff is here on the page, but don't look at it for purposes of your index? Any thoughts on that? Why would that even be a thing? It's okay if you don't know, but yeah. Yeah, but why?
You don't necessarily want to save everything or see everything because it would be infringing on privacy.
Possibly, but if Google can't see it, if Google can see it, then it's already open to the world. And if Google can't see it, because it's behind a paywall or security feature, then you don't have to worry about that. I mean, I suppose you could come up with some fringe cases where that was a thing, but again, if it's out there in the open, right? Why would the site want to say, yeah, we're letting everybody see this, but don't include it in your indexing process? Oh, that's fair. Okay, well, let's talk. So this is a little very brief intro into the advertising lecture. So we'll have the advertising lecture as the last of our 3 Google ones. So, and I saved this because I thought I did a decent job with it this morning. So I usually don't save stuff, but this I didn't want to, miss some spots. So number 1, many websites and pages are trying to make money, right? There's not a whole lot of them out there that are, just for fun. Okay. Number 2, in order to make money, you have to get some visitors, then make some sales or get people to click on ads, something like that. That's the standard model, right? Okay. So how do you get visitors? Well, you get visitors by ranking high in ordinary search results. That's free. If your site is a good match for a set of search terms and people have frequently clicked on the link and gone to the site and stayed there a while, Google's going to look at that and say, okay, yeah, your site's a good match and people seem to like it, and that's great. And you're going to stay high in the search results. Now, you could do a similar thing with ads, but ads cost a lot of money. So, you don't want to do that if you can get the same thing for free through regular search. The question then becomes, how do you rank high in search results? Well, number 1, again, be a strong match for search terms. So whatever people are looking for, that's an important part of your site. And number 2, be a link that users click and they stay with, right? They don't click on the link in the search results, go to the page, take a split-second look and say, nope, not what I wanted, and back out. Problem is, if your page is not a good match for users that are searching, it's gonna rank lower. And the thing is, this is the part that's not immediately obvious. Google basically maintains one single number for any website, right? It doesn't want to maintain a number for every website and every possible combination of search terms, because that's a whole lot of extra space. Basically, Google says this page has such and such, ranking relative to others. So if it does a good job when it shows up in the search rankings, that rank will be higher. If it sometimes does a good job and sometimes does a bad job, then it's not going to be ranking as high. Okay? So because of that, a lot of pages are going to exclude content that isn't relevant for matching so that they get a better overall user response, right? If your page is about selling shoes, you want it to, be primarily something that comes up when people are looking to buy shoes. You don't want to have some other random text somewhere on the site, have your page show up high in the, show up in the search results for some other search not related to buying shoes, and then people don't look at it, and then it drifts down in the rankings, and that affects, the search terms where you're actually making money. So that's the problem. Does that make sense? Again, this isn't a key part of this lecture. All right, I'm just trying to talk about why the robots text is there, because sites want to avoid being indexed on terms where they're not likely to, actually get customer visits, because that's going to ultimately affect their revenue stream. So what sort of content might websites want to exclude? Well, number 1, obvious one, if you have a news article and a bunch of people are making comments below it, right? People probably aren't coming to that web page to look at the comments. That's not what they're searching for, right? They want to read the news. So it makes sense, stuff like that, put that in the robots.txt, right? Say, yeah, don't include these comments when you're indexing that page. I don't want to, I don't want to have it show up as, car dealership in Dallas because some asshole in the comments decided to promote, their family business there, whatever. Okay. Number 2, any third-party content like iframes or ads, right? So iframes are it's like a web page within a page. When you let some other website have a little bit of control over your page. So an example of that is if you're just wandering around on the internet and some page is not directly affiliated with Facebook, like say you go read a blog article, but the blogger has let Facebook put in a Facebook share button on their page, right? So when you click that, what it's going to do is automatically share that article to your friends on Facebook. And people want to do that, but they don't really want to have their page index based on that, based on anything that's in that iframe or based on anything that's in the ads on the page, just, the page content itself. And of course, this is very situation specific, but anything you think might not be relevant to interested users finding your page. So for example, if you have you're a dentist, say, and you have some website up to promote your practice, what you want to advertise is the services you offer, where you're located, who you are. If there's like a whole biographical blurb about you down at the bottom, you might not include that. You might say robots.txt that because I don't want, somebody to say, oh, graduates of UIC 1997 and have my site show up in that because, somebody looked for that. So anyway, robots.txt is basically a way of really focusing what your site is about. So it only really appears in searches where it's going to be likely to be a relevant result. Okay. Anyway, the point of all that, again, not to do a deep dive into Google's ad system, but say, here's a robots.txt file, right? Why is that even there? Well, that's why it's there. All right. Does that make sense? Questions? Would you like to know more? Feel like you know enough? Okay. All righty. Well, the next thing, I got to draw another picture. Okay, so we're going to draw a picture of, if you've ever watched those cop shows, right, you've heard them talk about the dark web, right? Dark web? Dark web. All right, so we're gonna draw some stuff here. So first, I am going to draw the surface web. Do it like that. I hope that works. I hope I got the whole thing. Good. Okay. So the surface web open to the public. Okay. These pages are indexed by Google. I mean, unless they're like really bad, spammy, spam blog, scammer type pages, whatever, or security threats. But in general, if it's, a reputable page, yeah, Google wants to help people find it. Okay. So that's pretty much it. Open to the public, pages are indexed by Google. Okay. Then we have the deep web. I think pink works well for this. Let's see. Deep web is basically private pages, content behind paywalls or security features, right? Like password protection. These pages are not indexed. Why? Because Google can't really get its Google bots to them anyway. So imagine if one of you has an AOL account, you wouldn't want a Google bot to get your password and look at the contents of your email box and somehow make that available for anybody who was searching, right? That would be crazy. So that's the sort of stuff that's in the deep web. Okay? And there's a lot of pages there. If you think about everything that's behind a paywall or behind some sort of security feature, it's a lot of pages. All right. But the one that's interesting is this one that we're going to draw. And this is the dark web. I think orange worked well for this. Red didn't work too well. It kind of blurs in with the purple. So the dark web, okay? We have anonymized sites and users and sites, whatever, often for criminal activity. Okay? That's why the dark web shows up a lot on cop shows. All right, so that people are doing horrible things, or they're selling stolen credit card numbers, whatever. There's probably a human sacrifice out on there. You could have that done too. I mean, there's some messed up stuff out there. Okay, so again, we've talked about the surface web. The deep web is all the pages that are not indexed by search engines, right? So things like if there's an entire page, for example, that's denied by a robots.txt file, if you say, you know what, we have this page, we know it's open to the public, but we don't want you indexing it because whatever reason, we just don't. Hidden behind paywalls, right? Or any sort of secured content. All that stuff is deep web. Now, the dark web is more interesting, like I said, and it's designed for anonymous usage. So, anybody heard of Silk Road? Yeah? What do you know about Silk Road? It's okay. They sold drugs on it. Silk Road's no longer a thing, but yeah, it was a way to buy illegal drugs over the internet. Very good. Now, current status of Silk Road, dude's in prison for life or thereabouts, maybe 40 or 60 years. He's in prison for a very long time. Because, anytime you start selling drugs, eventually somebody's going to get killed. So, yeah, some people got killed. Now, the idea with Silk Road, this brings up, so we'll talk about the technology first. So the first one is a Tor browser. And a Tor browser is a way for users to keep anonymous. So the question basically, you visit a web page, there's some server that has to send you that web page. So in a sense, they have to know where you are. But if you want to stay anonymous, how can they send you the web page? Well, basically, there's a repeated series of encryptions that happen to scramble your IP address every time it goes through, some connection. And the way that works is essentially the website can deliver the page to your IP address by unspooling all that stuff, at every station. But the website doesn't actually know who you are. In each of those stations, they only know the input and the output. They don't know your final destination either. So kind of a neat thing. Now, this Tor routing was actually designed for US espionage services. We had this question, suppose you're a spy in a foreign country and you want to do something on the internet, right? Well, you can't very well on a monitored network just go to something like, the CIA's website and, send your boss an email. So they came up with this as a way that, agents could do stuff over the internet without actually, revealing who or where they were. But then as, obviously come to be used by other operations. The other one, I2P. I2P is anonymous website hosting. So when your website, like you, also has an IP address, that's a way that people can find it. And it works, if you want to think about it in a simple way, it's a lot like phone numbers. So if you know someone's IP address, you tend to have a pretty good idea of geographically where they are, right? Same thing as if you're using your cell phone, the tower has to know where you are so they can beam a signal to you, right? And if somebody's calling you on a landline, same thing. There's area codes, and then there's that 3-digit exchange, and then the 4-digit number. That back when they first implemented telephone networks, all that was based on, the physical layout of where the wires were. So I2P gives you another interesting problem. Suppose you want to set up a site to sell drugs over the internet. Well, you can't really run ordinary Google ads, right? Somebody goes into Google and types in the search, how to buy drugs. And, an ad for your website is going to appear at the top. And then 2 hours later, the feds are going to be knocking at your door. So it's not really a good model for that. So how do you get the word out? Well, we've all seen Breaking Bad, and we know how that worked out for them, right? Dude had some friends. They tried to deal out on a street corner. Somebody got shot. Somebody else went to prison. It's not a good system. But in theory, if you know people, you can talk, one-on-one with them and try to do it that way. But you can't do that because you don't know who the users are because of this Tor routing feature, right? So how do you do it? Well, the FBI actually reverse engineered the problem, and that's how they busted Silk Road in the first place. They said, how do you get the word out? Well, what would make sense is that you'd go to like kind of message board and you'd pretend to be an anonymous, disinterested user and say something like, hey, I just found out this really cool website where you can buy all sorts of stuff you can't get in regular stores, and you can buy it by the gram, right? Something like that. And in fact, that's what the FBI did, because they figured, whoever the first messages like that they find, the first promotional messages, if it's not from the dude who started the operation, it's definitely from some people in his inner circle. And so, yeah, they dug through message boards and eventually found some stuff like that. And the oldest one they found, they traced it right to the guy. And like I said, now he's in prison for a very, very long time. So I don't want anyone to think, come out of this lecture thinking, selling drugs over the internet. That sounds like a good idea. So let me give you one more. There was a child pornography ring run out of South Korea, and they were using this sort of anonymized stuff too. And they got busted, and hundreds of people got long prison terms. Because why? Because on one of their web pages, they had, even though you're using this, your system actually does have a regular IP address. And they had put that regular IP address somewhere in the content of one of their pages. And so, the authorities, they traveled to the site using all this stuff. They downloaded all the pages, scanned it, and they said, oh, that's probably your real IP address. So, they swarmed a bunch of agents on the house because they could figure out exactly what house it was at because of the IP address. And boom, like I said, a lot of prison time for those guys. Okay. So anyway, dark web's kind of neat stuff. People think it is anonymous, and I guess it is if you're a small player. But, if you become big enough to attract attention, they'll probably be able to find you somehow. All right. Next thing, indexing. So all the data from pages Google has visited are stored in basically a giant internet scale database system. And the indexing system, again, includes things like text, so how often it occurs, where it's located, combination of terms, images and videos, all that data, and the metadata for everything, not only for the page like creation and revision dates, but even metadata for images themselves. So for example, if you do a search on Google Images for pineapples, there's going to be a bunch of pineapples, but Google doesn't have AI to look at every one of these billions of images and say, this is a pineapple, this is not a pineapple, right? They're trusting what the tags are in the image. And when Google shows, listings of pictures like that, what it is if it actually is a pineapple, it's probably going to get some clicks on it. But if nobody clicks on it and Google keeps showing it, eventually it's going to fall lower and lower and lower in the rankings until it's not there anymore. So it's sort of a self-correcting system. Even if a picture gets mistagged, it'll eventually work out. Now, the main repository of all this data, so Google stores its extracted data, which has a fairly standard format, in a system called Bigtable we'll talk about later. And it's basically a relational setup. But the raw pages themselves, those are stored on document servers, and it's basically a NoSQL system. It's very similar conceptually to Facebook's pile of images that they store. Reason is, web pages, again, we've talked about, they don't have a standard format. So if you try to do that in a relational database, basically for each record, you have to allow enough space for the worst case scenario, for every field in every record, which means that there's going to be a whole lot of empty space in your database, right? Most web pages aren't going to use anything like the maximum. So it would be really bad. When Google's dealing with like trillions of web pages, they need to use their storage media efficiently, right? They can't just have it be 99% empty space. Anyway, but if you try to dig around and find more details about that, fair warning, it's pretty hard to find, right? This is kind of one of Google's special sauce things, so you're probably not going to find tremendous detail about this. All right. Okay, and this is the last slide. We're going to talk a little bit about this. Let's see, are we? No, I guess two more. We do two more. Okay, so indexing, right? that was the third topic of how Google gets the data. So imagine that you have a library full of books and you need to find some information on a topic, right? Obviously, you're not going to go through and scan through every book in the library to find what you're looking for, because that would be completely insane. No one has that kind of time. Instead, you're going to hope that there's an index that can let you look at a much, much smaller set of options. And the same thing at Google, right? A search query comes in, Google doesn't want to scan through every page. Google wants to have a lot of that work done in advance. So it can just say, oh, here are the search terms. I'm going to look up which pages those correspond to in the index, and I can rank those pages and deliver the best results. So for every search term, the index holds a list of all pages containing the term, right? And if there are multiple search terms, right, you enter in like 6 or 8 search terms in your query, it's still going to be that a fairly small set of web pages are going to hold all of them. Now, you might say, well, yeah, you can do a query, but it's still going to have like 10 million web pages matching it. And I say, yeah, okay, but suppose Google has 10 trillion pages in its database. 10 million is a lot less work than 10 trillion. So it is saving Google a lot of time, but it's also still a big problem, right? Again, searches for common words can easily return several million matches. All right. Now, the last thing, this has actually been a really interesting trend that Google's been doing in the last 15 years or so, is shifting towards a semantic approach to search results. So when we say a semantic approach, Google wants to try to figure out what the terms mean and then deliver matches based on that meaning. Okay, now I'll talk about some examples for that. First one. Anybody know who Galileo was? Who was Galileo? I heard scientist. That is correct. Would you like to provide more detail? What do we know about him? Do we know anything about him? Astronomer. Okay, that was one of his big things. Astronomer. I'll add physicist. You could add Italian if you wanted, but what else? Anything else? About when was Galileo active? That's a remarkably precise date. I'm going to say around 1600. Okay? I'm not saying you're wrong. I'm just going to throw that in there around 1600. Okay? Okay, so this is what we know. Now, based on this, suppose you run a search for astronomers of the 1600s. Galileo should definitely come up in that list, right? Because, you know, in case you didn't know, he was kind of a big fish in his time. So if you run a search for astronomers of the 1600s, Galileo should definitely show up, right? Because maybe you're looking for him, maybe you're looking for some of his contemporaries, whatever. But the thing is, if you're just matching based on the exact terms, unless a page has that exact phrase, astronomers of the 1600s, Galileo's not going to show up, even though he's a very important one, right? So you have to have some kind of system in place where it can work with that. I'll give you another one. World War II, right? Could also be written as WW2, WWII, W capitals. In the UK, they tend to call it the Second World War, okay? And any of those, if you type in one, you're only going to, on a pure text matching system, you're only going to get pages with the exact match. And that's a problem too, right? Because all of these things roughly mean the same thing, right? I'm going to, allowing for the fact that, you know, this is more UK usage, but they all do refer to the same set of events in history. So this is the thing. You'd like to have somebody be able to search any of those and have Google recognize, hey, these terms are all equivalent. If any of them show up, we should look at that. Okay? So that's the sort of thing that we're trying to do here, or that Google's trying to do. It wants to determine the meaning of search term groups, match that meaning to the web page content, right? And content, again, basically understood, combination of terms and object structure. So let's see, one more where it is meaning. I had a good one at the end of my morning lecture, but I'm losing track of what it was. So let's say I am looking for, I don't know. Suppose I'll do an obvious one. IDS 200, right? IDS 200 is a course at UIC. If somebody looks up for Introduction to Management Information Systems at UIC, right? Those things should be the same, and they should, show up in the same list of results. So this is a problem. Google needs to try to figure out a way to do this. Now, they've gotten a lot better at it over the last 15 years. 25 years ago, again, Google was basically just a combination of PageRank and are the terms there exactly as you typed them in. But from about 15 years ago, Google's been mixing in more of this semantic type stuff to try to say, these sets of terms are the same, and we can include those as distinct options. For example, Chicago means one thing, and Cubs means one thing, but Chicago Cubs, right? That means a thing that's separate from both. If somebody comes to Google looking for Chicago Cubs, Google by now knows that they mean the baseball team, not just pages that happen to contain these two words. Okay? All right. So stuff like that is what Google's doing with this semantic stuff. Anyway, we'll have more to say about this on Monday. This is a good break point, and have a good weekend, everybody.